Rocket launches today are a pretty routine venture, whether it's sending astronauts to the ISS or launching expensive satellites. And for the past 70 years, some of our most inspiring missions, from NASA's Apollo program to SpaceX's Demo 2, have launched from Cape Canaveral, Florida. But what's so special about this location? Cape Canaveral sits off the east coast of Florida, roughly 3,200 kilometers from the equator. This location is the perfect staging ground for rocket launches, as it provides a speed boost and energy savings for our launches. You see, as the Earth rotates, it naturally generates kinetic energy, rotating slowest at the poles and fastest near the equator. This means that during launch, a rocket gets a generous speed boost assisted by the natural rotation of the planet. But one of the most consistent hurdles we face when sending rockets to space is actually reaching a high enough speed to enter orbit, over 40,000 kilometers per hour specifically. We call this speed the escape velocity. Basically, it takes a lot of energy to propel a rocket with enough force to overcome Earth's gravitational pull. But what's really interesting is that the energy required to achieve escape velocity changes based on where you are on Earth. So depending on how close the launch is to the equator, the greater the speed boost it'll get from the Earth's natural rotation. Because it's located about 28.5 degrees north of the equator, achieving escape velocity from the Cape takes roughly 0.3% less energy compared to launch facilities at higher latitude locations. And I get it, that doesn't sound like much at all. But these small wins really do have big impacts on the mission planning process. The speed boost allows for the use of less onboard fuel, which converts the cost savings that can help us carry bigger mission payloads. So much so that Saturn V, NASA's heaviest rocket, launched from the Cape. Another factor that makes the Cape ideal is its favorable azimuth limitations. Simply put, this is the direction the rocket travels along the horizontal plane after launch. Lying between roughly 35 and 120 degrees, the Cape's azimuth limits provide a clear path toward the Atlantic Ocean that doesn't loom over populated areas. This makes the launch safer in the case of rocket failure or falling debris.